All right, let's get right into it. If your exam is just around the corner and you need to lock down similar triangles, you are in exactly the right place. This is your ultimate 5-minute revision guide to make it all click. Are you feeling totally buried under a mountain of theorems and formulas? Yeah, don't worry, you're not alone. We're about to take this whole topic, which seems kind of complex, and make it super simple and memorable. And we're going to do it fast. So here's our game plan. We'll kick things off with the big idea of similarity. Then we'll master the 3 tests you absolutely need to know. After that, we'll unlock the powerful theorems that come from them, use it all to solve a real-world problem, and then, the best part, we'll wrap it all up in a single formula sheet you can screenshot for your notes. Okay, first things first. What does it actually mean when we say 2 triangles are similar? Let's nail this down, because everything else builds on this one idea. So, in geometry, similar has a really specific meaning. It's all about having the exact same shape, just maybe a different size. You know, like a photo and a bigger print of that same photo. For triangles, this boils down to 2 simple rules. First, their matching angles have to be equal. And second, their matching sides have to be in the same ratio. They're all scaled up or down by the exact same amount. Now, this is a big one. People get similarity and congruence mixed up all the time. Just think of it like this. Similar triangles are like siblings. They look alike, but one might be taller than the other. Congruent triangles, they're identical twins. Same shape and same size. Notice the symbols too. That little wavy line, the tilde, is what we use to say is similar to. So, how do we prove 2 triangles are similar without having to check every single angle inside? That would take forever, right? Well, that's where these next 3 tests come in. Think of them as your essential toolkit for solving any similarity problem. Our first tool is angle-angle, or AA similarity. And honestly, this is the one you're going to use most often. It's the simplest and, a lot of the time, the most powerful test you've got. The rule here is just so simple. If you can find just 2 angles in one triangle that are equal to 2 matching angles in another, that's it. You're done. The triangles are similar. You might be wondering, why only 2? Well, if 2 angles match up, the third one has to match too, since they all have to add up to 180 degrees. All right, next tool in the box. This time, we're shifting our focus from the angles to the sides. This is the side-side-side similarity test. For SSS, all you have to do is check the ratios. Is the ratio between all 3 pairs of matching sides the same? So, for example, if every side of the bigger triangle is exactly double the length of its buddy on the smaller one, then you've proven they're similar. Simple as that. And the final tool in our kit is side-angle-side similarity. You can probably guess what this one's about. It's kind of like a hybrid of the first 2. Now, the key word here, and you really got to remember this, is included. You need 1 pair of equal angles, but it has to be the angle that's squished between the 2 pairs of proportional sides you're looking at. If you have that specific side-angle-side setup, the triangles are similar. If it's any other angle, the test won't work. Okay, so now we have our toolkit, but what can we actually do with it? Well, these tools unlock some seriously powerful theorems that are basically major shortcuts in geometry. First up is a real heavy hitter, sometimes called Thales' theorem. This one is incredibly useful when you're dealing with parallel lines inside a triangle. This is where similarity gets really, really cool. If you just draw a line through a triangle that's parallel to the bottom side, you automatically create a smaller, similar triangle right at the top. And this theorem tells us that the line slices the other 2 sides proportionally. It gives us a super direct way to find missing lengths. And now for a theorem I bet every single one of you knows, Pythagoras. But here's a fun fact you might not know. One of the coolest ways to prove it comes directly from the similar triangles you can make inside a right-angled triangle. We all know the formula, right? A squared plus B squared equals C squared. But it's not just some random magic rule. It's a direct consequence of the proportions you get when you split a right triangle into smaller, similar triangles. See? It's all connected. All right, theory is great, but let's see how this all works in the real world. We're going to use our toolkit to solve a pretty classic problem. So here's the setup. We've got a person, a lamppost, and their shadows. Now, the most important phrase here is at the same time. That's our big clue. It tells us the sun is hitting them at the exact same angle. Okay, let's break it down. Step 1, just picture the 2 right-angle triangles. Easy. Step 2, we got to prove they're similar. Well, the person and the lamppost are both standing at 90 degrees to the ground. That's one angle. And the sun's angle is the same for both. That's a second angle. So we use our AA similarity test. Boom, they're similar. Step 3. Now we can set up our ratios. Height over height equals shadow over shadow. Finally, step 4 is just the algebra. Plug in the numbers and solve for that unknown height. And the answer is 4.95 meters. I mean, think about that for a second. We just figured out the height of a tall lamppost without ever leaving the ground, all thanks to that simple AA similarity test. That's the real power of geometry right there. All right, you made it through the concepts, the tools, and the real-world problem. And now for the grand finale. This is the slide you're going to want to save for your final revision. Get your screenshot button ready. And here it is, your entire chapter all on one slide. We've got the main idea of similarity, we've got our 3 essential tests, angle-angle, side-side-side, and side-angle-side. And our 2 key theorems, the basic proportionality theorem and the one and only Pythagoras. This right here is your ultimate revision cheat sheet. You know, the main thing to remember is that this math isn't just stuck in your textbook. You can see it everywhere, in bridges, in art, even in your own shadow. So I'll leave you with this little challenge. As you go about your day today, just look around. How many similar triangles can you spot out there in the real world? Happy revising!